Hi students, welcome back to the Google Classroom of Plus One Statistics, Chapter 7 Correlation. How are you children? I hope all of you are safe and fine there at home. In the earlier chapters, we have studied univariate distributions where observations were given on a single variable. We obtained a measure of central tendency like the arithmetic mean, median, mode, etc., and a measure of dispersion like the standard deviation of the set of values of the variable. Now, suppose we have observations on two variables, x and y, for several individuals. We have a bivariate distribution of x and y. We can still calculate the central value, arithmetic mean, median, etc., and dispersion like standard deviation of each variable x and y separately. However, we would also like to know if there is any association between the values of the two variables. We would like to know, for example, how does the value of one of the variables change if the value of the other increases or decreases by a certain amount? Is the change in the same direction and in the same proportion, or change is more or less proportionate and in the reverse direction? If the change in one variable results in corresponding change in the other variable, then the variables are said to be correlated. We will study correlation in detail in this chapter. Correlation, a linear association between two random variables. Correlation, a linear association between two random variables. Correlation analysis show us how to determine both the nature and strength of relationship between two variables. When variables are dependent on time, correlation is applied. Correlation lies between positive 1 to negative 1. So the value of correlation is always lies between positive 1 to negative 1. A zero correlation indicates that there is no relationship between the variables. A correlation of -1 indicates a perfect negative correlation between these two variables. A correlation of +1 indicates a perfect positive correlation between the two variables. Types of correlation. There are three types of correlation: type 1, type 2, and type 3. Correlation is commonly classified into negative and positive correlation. The correlation is said to be positive when the variables move together in the same direction. When the income rises, consumption also rises. When income falls, what happens? Consumption also falls. Sale of ice cream and temperature move in the same direction. The correlation is negative when they move in opposite directions. When the price of apples falls, its demand increases. When the price rises, its demand decreases. When you spend more time in studying, chances of your failing decline. When you spend less hours in your studies, what happens, children? Yes, chances of scoring low marks or grades increase. These are instances of negative correlation. The variables move in opposite direction. What are the methods of studying correlation or techniques for measuring correlation? Three important tools used to study correlation are scatter diagrams, Carl-Pearson's coefficient of correlation, and Spearman's rank correlation. This Spearman's rank correlation method is deleted for the year 2020-21. So you have to study both these methods, scatter diagram method and Carl-Pearson's coefficient correlation method. A scatter diagram is a useful technique for visually examining the form of relationship without calculating any numerical value. In this technique, the values of the two variables are plotted as points on a graph paper. From a scatter diagram, one can get a fairly good idea of the nature of relationship. In a scatter diagram, the degree of closeness of the scatter points and their overall direction enable us to examine the relationship. Children, look at this picture. If all the points lie on a line, the correlation is perfect and is said to be in unity. If the scatter points are widely dispersed around the line, the correlation is low. The correlation is said to be linear if the scatter points lie near a line or on a line. Children, look at this picture. This scatter diagram shows all the points are to be in one line. Okay, all the points are perfectly correlated. These points are lie on a line and the correlation is perfect and is said to be in unity. So this is very good fit. Then next one, in this scatter diagram, the points are widely dispersed around the line. These points are widely dispersed around the line. The correlation is low. Here the correlation is perfect and is said to be in unity, and here the correlation is low because these points are scattered and widely dispersed around the line. So this is moderate fit. Points clustered closely around a line show a strong correlation. The line is a good predictor with the data. The more spread out the points, the weaker the correlation and the less good the fit. The line is a regression line and the equation y is equal to bx plus a. This is the equation, regression equation. Y is equal to bx plus a. Children, look at this slide. Scatter diagrams spanning over figure 7.1 to 7.5 gives us an idea of the relationship between two variables. Children, scatter diagrams spanning over figure 7.1 to figure 7.5 gives us an idea of the relationship between two variables. Look at here. Figure 7.1 shows a scatter around an upward rising line indicating the movement of the variables in the same direction. When x rises, y will also rise. When x rises, y will also rise. This is a positive correlation. Then in figure 7.2, this is figure 7.2, and the points are found to be scattered around a downward sloping line. This is a downward sloping line and the scattered points, the points are scattered around a downward sloping line. This time, the variables move in opposite directions. When x rises, y falls and vice versa. This is a negative correlation. Okay, this is a negative correlation. Then in figure 7.3, there is no upward rising or downward sloping line around which the points are scattered. This is an example of no correlation. This scatter diagram is an example of no correlation. Then next one, figure 7.4. This figure 7.4 and 7.5, the points are no longer scattered around an upward rising or downward falling line. The points themselves are on the lines. This is referred to as a perfect positive correlation and perfect negative correlation respectively. So this is a perfect positive correlation and this is perfect negative correlation. And this is the example of positive nonlinear correlation and this is the example of negative nonlinear relation. There is no lines, so this is negative non-linear relation. Okay. Children, let us conclude today's session by recollecting all the points. Correlation means a linear association between two random variables. When variables are dependent on time, correlation is applied. Then correlation lies positive 1 to negative 1. A zero correlation indicates that there is no relationship between the variables. A correlation of negative 1 indicates a perfect negative correlation. A correlation of positive 1 indicates a perfect positive correlation. And there are different methods of studying correlation: scatter diagram method, Carl Pearson's coefficient of correlation method, Spearman's rank correlation method. So children, please note that the corresponding notes and test paper are also attached along with this video. Make use of all these available resources, study well and attend the test paper without fail. Thank you.